Okay, you guys, this is your last flipped classroom video that you're watching. So the way that I would start this problem is to start by the degree. So at this point, degree and end behavior should be very natural to you. These should be taking you a minute to do. So I have 1, 2, 3, 4 x's because this one is squared. But because of this negative, I know that my polynomial is going to start with negative x to the 4th, and then there will be some stuff after it, okay? So the end behavior looks like this. When I describe the end behavior using that notation, remember, it means as x approaches infinity, y approaches negative infinity, and when x approaches negative infinity, y also approaches negative infinity because they're both facing down. Now, p of x is just another way of saying y. This wants to know where is y equal to 0. Well, I'm just asking you for the x-intercepts. Remember, wherever y equals 0 are my solutions. So x is equal to 0, x is equal to 2, and x is equal to negative 3 with a multiplicity of 2. Okay, so I'm going to sketch my graph. Here's 0, 2, negative 3. And I know that because this is 0, when I try to find the y-intercept, this is all going to 0 out because 0 times everything will just be 0. So that's all I have. Okay? So I'm going to start, I know here's my end behavior. That's kind of how I always start graphing. And I need to bounce at negative 3. Because this is a multiplicity of 2, remember this is a turning point and I need to bounce here. If you're still having trouble with that, please look back at the video from 2 days ago, okay? So I'm going to bounce here, I'm going to go straight through 0 and straight through at 2. So that's what my graph looks like. Now I don't know how high this is, I don't know how low this is, you know, you guess. That those parts you're not going to know till you get to calculus. So you're just making, there's a turning point and here's a turning point. So I'm going to label everything I have on my graph because that's going to be helpful for the next thing that we do. So here's negative 3, here's 0, here's 2, 0. And the last thing I'm going to write on my x-axis, this goes to infinity and this goes to negative infinity. Okay? And again, that will help you in a second. So the last new thing that we're talking about is find where p of x is greater than 0. Remember, p of x is just another way of saying y. I'm asking you, where is y greater than 0? So I'm going to draw a line. Here is y is equal to 0. It happens on the x-axis. This blue line is where y is equal to 0. So if I want to know where is y greater than 0, I want to know everything, all my values above the blue line. That's everything greater than 0. Okay? So I'm going to highlight that. That's this right here. This little part is the only part that's above my blue line. So remember, like increasing and decreasing, when we want to find where p of x is greater than 0, our answer is always in terms of x. Okay? Not y, just x. So I'm going to answer this in terms of x. Well, here is x is 0. From 0 to 2 on my x values, that's where the graph is greater than 0. That's where the graph is above the x-axis. So I'm going to write from 0 to 2. You're always going to answer these questions in interval notation. And I need parentheses here because this is just a greater than sign. Remember, a greater than sign is parentheses. Greater than or equal to would include a bracket. Okay? So similarly, I want to find where p of x is less than 0. I want to know where that graph is below the blue line. So I'm going to highlight that in a different color. Okay? And noticing that I only want to know what's below the line. I don't want to know what's on it or above it. So you have to be careful with that negative 3 because that negative 3 is not below the line, it's on the line. So I'm going to actually have 3 intervals, okay? I'm going to have from negative infinity, because I'm just looking at my x's, to negative 3. Now I'm stopping at -3 because 3 is not included. It's on the line. I don't want to know where it's equal to 0. I want to know where it's below 0. Then I'm going to pick back up at -3 to 0. Now again, because I have parentheses, this is showing me that at -3, that was not below the blue line, that was on the blue line or above, okay? And the last interval I have is this last blue section, which is 2 to infinity. So again, be careful with what's on it, above it, below it. And you feel free to use highlighters to kind of shade, okay? So the very last thing that we're talking about is to find all solutions of the following equations. Remembering the word solutions just means find me the x-intercepts. Okay? So in the past, with the last couple of days, we've used the rational roots test and synthetic division to find the x-intercepts. Now you can still do that. That still works. This is just one more way for you to find the solutions. And a lot of times this is easier if you know how to use it. So I'm going to show you this last way, and then you can decide kind of what you want to use, okay? So this type 1, my job is to find the x-intercept. So I need to solve for x. So this type is called, you find the GCF, you factor out the GCF, and you use the zero product property. So I want to find what both of these have in common. So the GCF in this problem is x. They both have an x in there. So I'm going to factor that out. And what's left is x squared plus 4. And I still have it equal to 0. Okay? So I'm going to set both of these equal to 0. I'm going to say x equals 0 and x squared plus 4 equals 0. I'm going to have to subtract 4. And when I square root, remember the square root of -4 turns into the square root of 4 times the square root of -1. So I should get plus or minus 2 times I. There comes that I again because of that square root of -1 turns into that I. Okay? So that's type 1, GCF. Easy peasy. Type 2 is probably the hardest type, and again, you can use the rational roots test and you can use synthetic division. That will always work. So if this type is too confusing for you, it's okay. So type 2 is to factor by grouping. Now you use this type when you have 4 terms. You only use it when you have 4 terms. So that means I have 1, 2, 3, 4 numbers. That's how I know I can use it. Okay? So what happens is you group. So I'm going to group these first 2 together, and I'm going to group the second 2 together. So I'm going to take a GCF out of my yellow group. Okay? So I'm going to take out what they have in common, which is x squared. So both of these have an x squared in common. What I end up having left is 2x plus 1. So that's just for the yellow. For the green, what they have in common is -16. I'm taking out that negative so that what I have left is 2x plus 1 again. What ends up happening is they end up having a common factor. In order for this to work, whatever's in the parentheses have to match, okay? So now that they match, that's what I'm going to factor out. And what I have left is x squared minus 16, and all of this is set equal to 0. Okay? So whatever matches, that's what you pull out. So I'm going to now solve for x. So 2x plus 1 equals 0. X equals -1/2. And x squared minus 16 equals 0. X equals plus or minus 4. Okay, last type, and then we're done with the video. The last type is called 4-2-0. Type 3. 4-2-0 exponents. And this type occurs, let me block this off. This type occurs when you have an exponent of 4, 2, and this exponent is really 0, right? There is no exponent there. That's why we're saying 4, 2, 0. What ends up happening is I'm going to try to factor it just like I normally do. So I'm going to think of two numbers that multiply to give me -6 and add to give me +1, because there's a 1 here in front of that x squared. So I'm thinking +3 and -2, right? Those two multiply to give me -6 and add to give me 1. The only difference in this problem, you guys, is instead of writing x and x, you're writing x squared and x squared. So when I multiply them, I get x to the 4th. That's it. So I like this type because I think that all of you can do this. And we're going to set each of these factors one more time equal to 0. So x squared plus 3 equals 0, and x squared minus 2 equals 0. So I get x equals plus or minus root 2. So there are two of my answers. I need 4 altogether since my degree was 4. And now x squared equals -3, which means x equals plus or minus root 3i. Remember that square root of that negative turns into I. Okay? So we are all done with Flipped Classroom. Please go back and visit any videos or notes that you don't understand, and I will see you guys tomorrow.